Hello everyone, welcome to the 4.3 notes. These notes are about rates of change in other applied contexts. So basically that means we're going to do a variety of problems today about finding the rate of change, about finding the derivative, but they're not going to do with motion problems. So position, acceleration, velocity is not something we're going to talk about. But here are just the skills that you use when you solve these problems. And again, you have kind of already been doing these things, so I'm just trying to put them all in one place. So first thing when you see a problem like this is you're going to find, or you're going to approximate, the derivative. Sometimes you're actually going to get to use the calculator to find the derivative. And so we'll do a couple problems today where we have calculator active problems. Your skill 2 is you're going to interpret the derivative in context with appropriate units. And then skill 3 is you're going to interpret when a quantity is increasing or decreasing based on the derivative. So let's just jump into a couple problems. This first one says, LeBron James studied for an English test today and learned 80 vocabulary words. In 10 days, he will have forgotten every word. The number of words that I remember 2 days after studying is modeled by, probably should say he remembered, is modeled by W of t equals 80, which is 1 minus 0.1 t squared when 0 is less than or equal to t, which is less than or equal to 10. What is the rate of change of the number of known words what is the rate of change of the number of known words 2 days after studying? So the big thing I know here is it says what is the rate of change, and then it says 2 days after studying. So it's a specific time and it's a rate of change. And so I know that means I want to find the derivative. So that means I'm going to find the derivative, and specifically I'm going to find the derivative at 2 days. And so I know that I'm not just using like the slope formula, because that would say like over an interval of 2 days or something like that. And so my goal in this problem is to find W of 2. But first, I'm trying to find W prime of 2. So first, we're going to have to go to our equation W of t, which is 80 times 1 minus 0.1 t squared. And I'm going to have to start by finding the derivative of that. And so if I look at that function right up here, I'm going to notice that there is an inside function, and then there's an outside function. And so I'm going to start by finding the derivative of this function. And so I'll take the derivative of the outside, so 80 stays out front. I'll times that by 2, 1 minus 0.1 t, and then 2 minus 1 is 1. And now I'm going to multiply that by the derivative of the inside. 1 minus 0.1 t is going to be negative 0.1. So I'm just going to highlight this part was like the derivative of the outside part. This was the derivative of the inside. And now I'm going to go ahead. I have the derivative now, and I'm going to plug in 2 for t. So I'm going to do 80 times 2, which is just 160. So I'm just going to go ahead and rewrite that as 160. And then 1 minus 0.1 times 2 minus 0.1, times negative 0.1. Going to just keep cleaning that up. 160. This will be 1 minus 0.2 times negative 0.1. And I'll just keep going. And I think this eventually gets us, you can plug it in the calculator, negative 12.8. So W prime of 2 equals negative 12.8. And so that is the derivative at 2. And so what we have to talk about now is what does that actually mean? So this is going to want us to put our answers like in little sentences. So what does this actually mean? Well, what this means is the number of words LeBron knows two days after studying is, so it's a negative number, so I'm going to say is decreasing. Then my big derivative language is going to come out at a rate of 12.8 words per day. So 2 things I want you to notice here. is that I wrote decreasing, and so I wrote decreasing here, so I no longer have to write negative 12.8 words per day. I just have to write that. And then my little note over here was just to remember to round to the 1,000th place. 1,000th place. When you do this, don't round, and like round at the very end. Don't round as you go. So that is the answer to this one. The number of words LeBron knows 2 days after studying is decreasing at a rate of 12.8 words per day. We're going to do a couple more, and then we're going to start using our calculator, so these will come by a lot quicker. But this says a pool is being filled. The following function gives the pool's water level in centimeters after t seconds. W of t equals 4 times the square root of t plus the natural log of t plus 1. What is the rate of change? So big word here, rate of change on the pool's water level at 100 seconds. And so the fact that it says rate of change at a specific place tells me that I'm using the derivative. And then again, you can use this and you can find the derivative using the calculator, but we're not going to do that yet. So I'm going to just find the derivative of w of 2, but I'm going to rewrite it real quick because it's not ready for you to take the derivative of it. So I'm going to rewrite the square root of t as t to the 1/2 power, and then everything else gets to stay the same. Now I'm going to start by taking the derivative. So I'm going to do 1/2, pull that down. So 4 times 1/2 is 2 times t to the 1/2 minus 1 power, which is negative 1/2, plus this is chain rule. So the inside function is t plus 1. The outside function is the natural log. And so the derivative of the natural log is 1 over x, or sorry, it'd be like 1 over t. So I'm going to make it 1 over t plus 1. And then the derivative of that inside part right there is just 1, because the derivative of t plus 1 is 1. So that is my derivative. I'm going to rewrite this real quick. I'm going to simplify this. This is going to be a little easier to simplify so I can plug things back in. So all I did here is that I moved this 1/2 to the bottom, and then I put it back into radical form because this negative 1/2 moves it to the denominator, and then I just put it back in its square root form. And now specifically I want to find the rate of change at 100 seconds. So I'm going to plug in 100 here. So I'll have 2 over the square root of 100 plus 1 over 100 plus 1, which equals 2 over 10 plus 1 over 101. And this will simplify to be 0.210. And so that is our derivative at 100, but now we have to put it into context. So I'm going to write at 100 seconds, the pool's water level it's positive this time, so it's increasing at a rate of 0.210 centimeters per second. And I'm getting centimeters per second just from the top. Okay, a couple more problems. Some of these will be a little quicker. So this one says people enter an amusement park at a rate given by E of t equals 15,600 divided by t squared minus 24t plus 160, where E of t is in people per hour and t is in hours after midnight. Find E prime of 11. Use correct units, interpret the meaning of the value in the context of the problem. So this is an AP calculator test problem. And so if you have a calculator, you should always use that, because this says this function right here is the people entering an amusement park at a rate. So it's at a rate given by this. But basically this first thing it wants us to do is it wants us to find E prime of 11, and specifically we're finding the derivative at 11, which means I can use the calculator here. So if I can use the calculator, I will use it. So I'm going to go over real quick and I'm going to get my calculator app out, and so I want you guys to do the same. Gotta find it real quick. Calculate 84. Okay, so I'm going to type this function. So remember, what you do when you use the calculator is you go to math and then you scroll down to 8 where it says in derivative, and you're going to write your function in here. Be really careful how you write it in. I'm going to write it in parentheses. So I'm going to do 15,600 divided by x squared minus 24x plus 160, because that's my equation, and then specifically I'm finding x at 11. And so what I'll get out there is 107.958. And so I'm going to just go ahead and write that down real quick. E prime of 11 equals 107.958. And so what this calculator, this is a AP calculator test problem, what it's assessing here is not whether you know how to find the derivative. What it's assessing is that you can interpret the meaning of this. And so that's what we're going to do here. So we're going to start with, I'm just going to go ahead and start with my time. So at 11 hours, and before I go on, the original function represented the people entering an amusement park at a rate. So that original function is actually already a rate. And so what's happening here is if we're taking the derivative of something that's already a rate, we're taking the rate of a rate. And so what I'm going to write here is at 11 hours, the rate of people entering the park, at 11 hours, I'm going to add this after midnight, because it's not just like after 11 hours, right? At 11 hours after midnight, the rate of people entering the park is increasing because it's positive at a rate of 107.958 people per hour, because since the original function was a rate, then we have to do the rate of a rate, and every time you add a rate, that adds another per hour. So people per hour. And so that's our answer here. And so what this is testing again is not that you know how to plug in the calculator, but you know what this means. Okay, I think we have two more and then we'll be done. So this one says a local bakery opens at 7 a.m. and the number of people in the bakery can be modeled by B of t equals 24.6 sine pi t divided by 10 times 8 minus t over the interval 0 is less than or equal to t, which is less than or equal to 8, where t is measured in hours and 7 a.m. corresponds to t equals 0. Is the number of people in the bakery increasing or decreasing at 1 p.m.? Okay, so we're, this function right here, let's go back and what is this function talking about? So this is the number of people that are in the bakery. So it says b of t and the number of people in the bakery. And so this isn't a rate or anything like this. The original function is the number of people in the bakery. And so if we want to know how the number of people is increasing or decreasing at a specific time, we need to find the derivative. And so we're going to have to find the derivative here. But the question is, where are we finding the derivative? So it says that we want to find the derivative at 1 p.m. But I'm not going to plug in 1 here because t equals 0 corresponds to 7 a.m. So we have to think about how many hours is 1 p.m. after 7 a.m. So 8 a.m. I'm counting on my fingers here, so you can do it with me. 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m., 1 p.m. So I counted 6 fingers. So this is specifically asking for the derivative at 6. And just like last time, I'm going to go to my calculator because this is a calculator problem. I'm going to go to Math 8. Oh, no, I did something weird. Okay, sorry. Math 8. I'm going to type in this function, 246 point, okay, wait, real quick. I'm going to just check my modes here. Okay, so make sure your calculator's in degrees when you do this because that's a sine function. So 24.6 sine, and then pi, I'm using x instead of t because you don't use t in the calculator. I'm coming outside of here and I'm doing 8 minus x, and then I'm typing in x equals 6 here. And so the answer is negative 28.172. That's what my calculator told me. And so the question says, is the number of people in the bakery increasing or decreasing at 1 p.m.? Explain your reasoning. Well, this is a negative number, so I'm going to say decreasing because the rate of change at 6 is negative. It's kind of the same idea of velocity and acceleration, or velocity. Like if velocity was negative, that means the object was moving to the left. If it was positive, it's moving to the right. So if our rate of change is negative, that means something's decreasing. And if our rate of change is positive, that means something is increasing. So it's decreasing because the rate of change at 6 is negative. Last problem, it says challenge, but this one's actually not that bad. It's not as bad as you think it is. So it says the penguin population of an island is modeled by the differentiable function p of t for 0 is less than or equal to t, which is less than or equal to 40, where t is in years. There are 100,000 penguins on the island at t equals 0. The birth rate for the penguins is modeled by b of t equals 1,000 e to the 0.06 t penguins per year, and the death rate is modeled by d of t equals 250 e to the 0.1 t penguins per year. That's a mouthful. Is the penguin population increasing or decreasing at t equals 5 years? Give a reason for your answer. So before we move on, let's just look at what these two different functions mean. So b of t, it says, is a birth rate. Okay, So birth rate, we already have that. And then it says D of t is the death rate. And so is the penguin population increasing or decreasing? Well, to answer that question, if the population was increasing, that means that the birth rate has to be greater than the death rate. And specifically, we're talking about t equals 5. And so what's interesting about this problem is that we don't actually have to take the derivative anywhere here because we already have our rates. Is the penguin population increasing or decreasing? You would answer that question based on what the rate is that year. And so what I'm actually going to do is I'm going to create a new function. I'm going to say r of t, and that's just going to stand for the rate overall. And if r of t is positive, that means that my rate is increasing because I'm going to make r of t, that function, I'm going to make it b of t, the birth rate minus the death rate. And so if the birth rate is higher than the death rate, that means the population is increasing. If when I do b of t minus d of t and it comes out negative, that would mean the penguin population is decreasing. So specifically, well, I'm going to, I guess, plug in those two functions first. That'll be 1,000 e to the 0.06 t minus 250 e to the 0.1 t. And then specifically, I am concerned about the rate at 5. So I'm going to plug in 5 here. But notice, I'm not taking any derivatives here because I already have the rates. I don't need to take a derivative because I'd be doing more work. If I plug that in my calculator, I'm not going to do it, but you guys are welcome to do it. I'm going to get 937.678 out. And that number is greater than 0. And so what that means is the penguin population is increasing at 5 years because r of 5 is greater than 0, which essentially means that the birth rate is higher than the death rate. And so that is how you do these problems. You really just have to use some logical thinking, think about what you have and what do you need. Good luck.